Hello, welcome to the other session of shared teaching. Our team consists of 3 people. I am Anjulekshmi.
I am Aswathy A.S.
I am Deepika D.
Yes, today we are going to deal with the topic separation of mixtures. Okay, so on to the PPT. You all know what a mixture is. Let me turn my rotation. Okay, you all know what a mixture is. When 2 or more substances mix together with each other without chemically combining, they form a mixture. Mixtures are of 2 types: homogeneous mixture and heterogeneous mixture. Homogeneous mixture, they uniformly mix and the parts do not appear separate. They are difficult to separate. Examples of homogeneous mixtures are air, blood. The heterogeneous mixtures, we can see the parts appearing separately. They are not uniformly mixed. They are easy to separate. First, let's deal with how to separate heterogeneous mixtures. Heterogeneous mixtures can be mainly separated by 3 methods: sedimentation, decantation, and filtration. To understand these 3 processes, let's see a video. Hope you can see my screen. I'm playing the video. So, about separation of substances. We are going to deal with separation of solid from liquids or heterogeneous mixtures in which liquid and solids are present. Solids are of 2 types: insoluble solids and soluble solids. Example of insoluble solids are sand in water, and soluble solids are sugar in water. So here we are going to deal with separation of insoluble solids from liquids. The 3 methods, as I mentioned before, we are going to see that in detail. They are sedimentation, decantation. First one, sedimentation. Sedimentation is a process in which heavier insoluble particles settle down at the bottom. Okay. The solid particles that settle at the bottom are called sediments. Now we can see it through an example. Here I am taking a beaker of water and mixing sand on it. Then in the next beaker, I am mixing sand and water. And after some time, what do we observe? Yes, the sand gets settled at the bottom of the beaker, leaving the water above clearer. The sand which settled at the bottom is known as sediments. This is the overall process of sedimentation. Okay. So now we got the clear liquid above the sand. We need to separate sand and water. That was our aim, right? So we go on to the next process. That is decantation. Now, what is decantation? Decantation is the process of pouring out the clear water slowly into another container without disturbing the sediments. So, as we have seen that the sand settled down and the water is left above, to separate both sand and water, we slowly pour the water in the 3rd beaker to a 4th beaker so that we obtain clear water in the beaker. This process is called decantation. Hope you understood. Now, let's see the 3rd thing, that is filtration. Filtration is very common to you, but it's very familiar to you. We actually filtrate tea leaves from tea. That is the basic filtration we see in our kitchen. It is the process by which two fine insoluble substances are separated by using filter paper. The two substances should be insoluble and we use a filter paper to separate them. The particles retained on the surface of filter are called residue. Now let's see the filtration which we conduct in a laboratory. For this, we take a beaker containing a mixture with water and insoluble impurities. Then we take a cone and a funnel, then we take a funnel and then we make a filter paper in the shape of cone and insert into the funnel. Then we take a conical flask. Then we take the beaker, that is the mixture we need to separate, and pour it onto the funnel. And we obtain clear water in the conical flask and the insoluble impurities are present in the filter paper. That is known as residue. I hope you understood the three processes: sedimentation, decantation, and filtration. Now let's see the other process to separate mixtures.
Okay, now we can see the processes: evaporation, distillation, crystallization, and sublimation. Let me share the screen. Anju, can you see the screen?
Yes, I can see. We can see.
Okay. Now, evaporation. What is evaporation? Evaporation is a process of vaporizing large quantities of volatile liquid to get a concentrated product. The factors affecting evaporation are temperature, surface area, agitation, atmospheric aqueous vapor pressure, atmospheric pressure on the liquid under evaporation, type of product required, economic factors. And into the details of these factors, the rate of evaporation is directly proportional to the temperature. So as temperature increases, the rate of evaporation also increases. The rate of evaporation is directly proportional to the surface area of the vessel. And the third factor is agitation, which is necessary for evaporation. The rate of evaporation is inversely proportional to the atmospheric aqueous vapor pressure. And the fifth factor is atmospheric pressure on the liquid under evaporation, which is inversely proportional. So type of product required and economic factor are also the factors which influence evaporation. Applications of evaporation. Industrial applications include many printing and coating processes, recovering salts from solutions, and drying a variety of materials such as lumber, paper, cloth, and chemicals. In the manufacture of bulk drugs, particularly in pharmaceutical industries. In the manufacture of biological products like insulin, enzymes, and hormones. Pharmaceutical synthesis process in API industry, pharmaceutical herbal extraction in herbal industries. These are the applications of evaporation. And now, sublimation. What is sublimation? The change of a substance from a solid to a vapor without ever becoming a liquid is sublimation. That is the direct change. There is no middle state like liquid. Sublimation is the process where a solid changes phase and turns directly into gas without passing through a liquid phase. As in the figure, you can see that dry ice, without melting into liquid, it is directly converted into vapor. And this is sublimation. Here you can see the image of camphor, which is very much familiar to you. Here the camphor, when it is placed in an open space, it will directly evaporate it will directly sublime to gas without moving to the intermediate liquid state. And this is dry ice. Here you can see in the figure that the dry ice, which is in the solid state, is directly converting into vapor state, where here sublimation occurs. And now the third concept, crystallization. Crystallization is a chemical solid liquid separation technique in which mass transfer occurs from a liquid solution to a pure solid. Spontaneous arrangement of the particle into a repetitive order. That is, you can see the regular geometric patterns in a crystal. And crystal can be defined as a solid particle which is formed by the solidification process under suitable environment in which structural units are arranged by a fixed geometric pattern or lattice. And the process of becoming a substance into crystal is crystallization. You can see in the figure the crystal structure of sodium chloride, NaCl, where it is having a fixed regular structure. And this is all about the three concepts I have to handle. Now we can move to other concepts.
Okay. We have discussed so far the separation of mixtures, and we have discussed about 6 methods. And the next 2 methods are distillation and chromatography. Let's check its details. Okay, the 6th method is distillation. What do you mean by distillation? It's the process of separating 2 or more liquids. And this is the experimental setup. And simple distillation works as water in the distilling flask boils. Here you can see the experimental setup for simple distillation. And here in the distilling flask, water boils and water vapor rises and it enters into the condenser. Water vapor is condensed back to water. That is, it is cooled back. The vapor cooled back to water state and pure water is collected in the receiver. Here we can see the mixture of salt and water. And from this, when we boil, the vapor rises and it condenses back to water. And salt and water gets separated. And things to remember while doing the simple distillations are thermometer and the bulb is placed at the opening of the distilling flask. In case of condenser, water enters the condenser from the bottom and exit through the top. In case of boiling chips, it ensures smooth boiling. And the next one is fractional distillation. Fractional distillation is used to separate one liquid from a mixture of different liquids that have different boiling points. That is, here we take the example of ethanol and water. To separate ethanol from water, the process can be used to separate miscible liquids with different boiling points. Liquid with lower boiling point will vaporizes first. For example, to separate alcohol from water. You all know that alcohol and water are miscible liquids and both are having different boiling point. So here the one with lower boiling point vaporizes first and we can separate it out. This is the fractional distillation method. And the next method for separating mixtures are paper chromatography. It uses a solvent to separate a mixture into its components. And the applications are separating dyes in ink, pigments in plants, amino acids obtained from proteins, and to identify poisons or drugs, and also to detect traces of banned substances in food. These are the applications of paper chromatography. Okay. Apply a small but concentrated spot of the solution on a piece of chromatography paper and suspend the chromatography paper in a beaker or boiling tube of solvent with the spot above the level of the solvent. Separation takes place because some components of the liquid mixture travel at a faster pace than other components on the paper or any other absorbent material. As the solvent travels up the paper, the mixture is separated into its respective components and we get a chromatogram. And a chromatogram of the separated components is obtained. And how to, this is the experimental setup for paper chromatography. And this is the experimental setup. Here we can see a lid, glass tank, and this is the chromatography paper. And also a pencil line is drawn and ethanol is taken in the beaker. And this is the one that we got as a chromatogram. And here you can see two colored spots and one spot of green food coloring. Okay, let's interpret a chromatogram now. Okay, for interpreting a chromatogram, here in this figure, you can see two colored spot and one spot of green food coloring and a solvent front line. The chromatograms shows two colored spots above the starting line. This means that the sample is a mixture or it is made up of two other substances. From the chromatogram we got, we can interpret that the sample is a mixture and it is made up of two other substances. And if we got one black spot like this, we can confirm that or we can interpret that the sample is pure or it cannot be separated into other substances. And the third one is like this one. And the chromatogram shows that no spots above the starting line. That is, it will be seen as a plain paper and the sample is insoluble in the solvent used and the solvent needs to be changed. These are the interpretation of chromatograms. Here we see three interpretations. Two colored spots, only one black spot and no spots. These are the interpretations of a chromatogram. And looking up to the applications of chromatography, analyzing ink dyes for forgery cases, analyzing food dyes to ensure that only permitted colorings are used in the foodstuffs. And the third one is checking whether pesticides on vegetables exceed the safe levels. And the fourth one is detecting the trace levels of drugs in urine samples. These are the applications of chromatography. Okay, hope you all understood today's session. And in today's class, we have discussed about sedimentation. We have discussed about 8 methods of separating mixtures: sedimentation, decantation, filtration, sublimation, evaporation, and crystallization. And in the last session, we have discussed about distillation and chromatography. Okay. Next, the review questions. First question, explain the difference between sedimentation and decantation. Second question, which method is used to separate colored substances from each other? And the third one, which method is used to separate crude oil? And the fourth one is, what is the difference between sublimation and crystallization? Okay.
And now the follow-up activity. You have 4 mixtures with you. 1, cornflakes and milk. 2, oil in water. Third one, salt in water. And the fourth one is sugar in water. Which of the following mixtures can be separated by filtration? How to separate a mixture of acetone and water? How will you separate a mixture of common salt, sand, and iron fillings? And these are the follow-up activities for you today. Hope you can answer all.
Yes, with this, we are concluding our session. Hope you understood the different process of separation of mixtures and the concept is very clear to you. If you have any doubt, feel free to contact us and thank you. That's all for today. Thank you.